Alright, up to this point we have learned how to differentiate functions explicitly, which means that y can be isolated. Y is by itself. So we can know the relationship between x and y specifically with y by itself. Now, oftentimes it's not easy or possible to get y by itself, and in fact our relation may not in fact be a function. And this often occurs when y can't be isolated. So a relation like that might be something like this, where it's not easy to isolate y, and we can still differentiate a relation like this, but we have to do it implicitly. So here's a function, x times y equals 1, that we can actually differentiate both explicitly and implicitly. So let's first of all do it explicitly, since we're familiar with that process. To do that, we need to get y by itself, and then I can apply the power rule. So the derivative of y with respect to x would be negative x to the negative 2, which is negative 1 over x squared. Alright, to differentiate implicitly, and again I'm trying to find dy dx, what I need to remember is that every time I come across a variable that isn't x, I got to remember that y is in some way related to x. I may or may not be able to know what that is. In this case, I do know that. I know that it's y equals 1 over x. But the basic point I'm trying to make is that you need to apply the chain rule when you come to any variable that's different than the one you're differentiating with respect to. So let's jump into this and hopefully you'll get the idea. We've got a product. So I'm going to do the first function times the derivative of the second. So the derivative of y would be dy dx, plus the second function times the derivative of the first, which is 1, equals 0. I can then isolate dy dx by subtracting y and dividing by x. Alright, and in many cases we're going to leave our derivatives like that. Now, because we actually know in this question that y was 1 over x, you'll notice that if you substitute this in place of y, negative 1 over x divided by x would be negative 1 over x divided by x would be multiplied by 1 over x. I get the same derivative as I had when I did it explicitly. So these processes are equivalent. This time we have the equation of a circle, and I'm going to differentiate this explicitly. In other words, I'm not going to try to get y by itself, even though I could. I'm just going to jump right in and differentiate implicitly. Again, I want to find the derivative of y with respect to x, which means that every time I come across a variable that isn't an x, I got to remind myself that y is in some way related to x, okay, and that the chain rule must apply. Alright, so here we go. The derivative of x squared is 2x. Now I come to y squared. Now I got to remember that the y is something involving x squared. So this is like a chain rule. So the derivative of the outside function, which is y squared, the derivative would be 2y times the derivative of the inside, which is y, is dy dx, because we don't explicitly know how y is related to x, equals the derivative of 4, which is 0. Alright, so if I subtract 2x and divide by 2y and simplify, I get my derivative as negative x over y. And that's the way I'll leave my derivative. If I wanted the slope of the tangent line at a specific point, I would have to enter both the x and y coordinates for the point of tangency. Alright, now let me just throw one more little thing in here. I'm going to take the same question, but this time I'm going to differentiate with respect to t. So you say, well, how can we do that when there's no t involved here? What you got to remember is that even though you may only see two variables in an equation, there may be a third variable to which each of the two given variables are related. So for example, in this equation, x might be in some way related to t. Y might be in some way related to t. And since x and y are both related to t, in some way they're both related to each other, which is what we're seeing here. So I've got to remind myself that as I differentiate this equation implicitly that every time I come across a variable that is not a t, I need to apply the chain rule. So here we go. The outside function is x squared, so the derivative of that is 2x times the derivative of x with respect to t. Well, since I don't know how x and t are related, I simply write down dx dt. I multiply them because that's the chain rule. Plus, again, y is related to t, so the outside function is the derivative of y squared, which is 2y, times the derivative of y with respect to t. Again, I don't know what that is. Explicitly, so I'll write down dy dt, equals the derivative of a constant, which is 0. And I was asked to calculate dy dt, so if I isolate dy dt by moving this to the other side, I'm going to end up getting dy dt is 2x dx dt, negative that is, divided by 2y, and then the 2's cancel out. So I have my derivative of y with respect to t, which is related to x, y, as well as the rate of change instantaneously of x with respect to t.